Okay, so welcome back to my channel. So today I will talk about stack in algorithm. Okay, so in computer science, a stack is a linear data structure that flows last in, first out, and this is leaf 4. Please remember this principle. That means the last element added to stack is the first one to be removed. To be equal something like this. We have a stack like this. It's like box, and we have a lot of stack like this. Yeah, like this. Okay. Sorry, this a little. Okay. So this is the default stack will look like, and we'll start to count from 0. This 1, 2, and go on, go on, go on. So the last element added to the stack is the first one to be removed. For example, I have a book like this. I have a book like this, a book called A, okay? And I add it to stack as this. For example, we have B and C here, and we add the book A to number 2 here. So when we take it out, yeah, then the book A is on the top. So we will take A out first. We take it out. And basically it's how the stack work. Think of it as a collection of items that stack on top of each other, and you can only interact with the topmost item. Okay, so let's take an example where we have an empty stack where we have nothing. Okay, we don't have this too. Yeah, we don't have anything. So we have object A, object B, object C, and we push it into stack C here. So we have item 0, okay, B into here, and we have item 1. If we want to interact with the stack, so we have to take the item B because B is on top of the stack, and if we push into item A, then the first item we interact will be item A. And if not, if we only have B and C, then the first item we interact is item B. Okay. So we have two primary operations performed on a stack are push and pop, and we call the action push an object into a stack is pushed. Yeah, push. It just like the and then push. Yeah, it's just like the method push in the array. We push like here. We have cow animal push cow. Then cow will go into here. Yeah. And if we push chicken, cat, dog, and we got this array. So the push work exactly like that. And the second operation is pop. Okay. The functions pop will take an item out. So for example, we only have item A inside this stack, and we pop it out. Yeah. So where we pop it to, where we pop it to? Well, it depends, but we just pop it out of the stack. That's all you don't need to know. And as operations often associate with stack include, so this not something that we call a method or function. This some kind of attribute that we need to care about. So we need to care. The first thing is pick or top, or what is the top object, or what is the top element. Okay. Okay. Let me undo this. So here, if we have object A, we start at 0. Object B, we start with 1. Object C, we start with 2. And object D, we start with 3. So I will call this stack is S D, okay, K. So the pick or the top most element will be D. Okay, this is empty. This is empty. We don't care about this. This thing is empty. We don't care about this. We don't care about what elements appear in stack. So the stack tree is the top most is the topmost element. So let's see where here. Yeah. Okay. So if I delete this and yeah, and stack only to C. Yeah. Then the topmost of the stack is C, and the STK number 2 will be the top. Okay, if I keep pop out C and I delete this, here I delete this, then the top is number 1, right? That's simple. Yeah, number 1. Okay. The second attribute you need to care about is the is empty. Is empty is a boolean. It is a boolean. Yeah, boolean. Boolean, and it will be true or false or false. It will be true or false, and this attribute will check if the stack is empty or not. In this example, the is empty will be false because we have 2 elements inside this stack. And the third attribute is size. Size determined by the number of elements in the stack. This simple. We have 2 elements here, so the size will be 2. Yeah, we have 2 elements. So if we have 3 elements, then the size will be 3. See, the size will be 3. Yeah. Right. And that's all about the stack. There are few important notations that you need to care about. Let me see. Okay, here. It's important to note that stack has a fixed size. If you keep pushing elements without popping them, you may encounter a stack overflow, which is a common cause of a program's crash. So the example for this crash will be like this. Imagine we are working with an Excel file, the Excel, okay, like this Excel, yeah, yeah, and you have name here, name here. name maybe a meter A. You give him a number is 1. Then you download, you type meter B. Here is 2. Then suddenly it should be meter C here and number 3 here. But because of the fixed sign here had a fixed sign and the crash happened, so it will cause an unexpected behavior that we do not uh, come from here to here to here, but because of crash we do not get into this place. Okay, it will skip it and it will go like this here, share here. This area will disappear. That's what relay example. Okay, I think that's all about stack. You may read more about the basic operation of stack, complexity, and space later. In the next video, I will go to lead code here, and I will solve 5 problem for you about the stack. Alright, my video is we end here today. Thanks for watching. See you later.